Recording? Yeah. Okay. Uh, cool. Let's start. Thank you guys for joining. This is a DSA series, and this series is basically take you from a very basics, from the ground to a very good level of DSA. Like ground from like what is DSA, starting from the number theory, which is a very basic stuff, including maths and everything, and then we will go up to graphs and all those things. And this DSA series is going to be a long, because DSA is itself a wide range of things, starting from the number of data structures and number of algorithms and question that you need to do to understand DSA. I would ask you to do not take it as interview purpose. Like it is for interview purpose, but believe me, if you start learning DSA, it will also improve your thinking about writing any code. It doesn't matter you are writing the code in backend, front end, artificial intelligence, anywhere. Like whenever you do questions on DSA, it will just open your mind, to a to extent to think multiple cases and to include everything when you are doing a coding part. So it's going to change your daily life, when you start DSA, and definitely it will 100% help you to improve in your interview as well. Interview, large company itself. And but I personally would ask you to please take this series as to improve your knowledge on this DSA, why we need it, and how you can use the TSA to improve your daily life productivity. And definitely I'll also include those examples where this DSA would help you in your productive day-to-day life. Little bit about myself. I have not added any slides here to about me, but let me just introduce myself. So my name is Ankit, and I'm currently working in the Gojek past 3 years, and I'm an Android engineer. I also do part time like open source part and talk about Android stuff. Um, and also I'm a part of an Android educator program where we teach Android to university students. So yeah, I think this DSA is to start so that other people who do not understand or like to do DSA, because I know if you are Android engineer, you mostly like to work on open source project and like to do your Android stuff, because DSA itself feel like overburden with your Android journey. But believe me, if you start using DSA, you will going if you understand something like anything. If you understanding Android, you like working on Android, right? So it's same like this. If you understand DSA, you will like to solve more question on DSA. Maybe one or two question daily, and it will definitely boost your like confidence in DSA. And that's going forward will also you will see your improvement in your interview as well. Cool. That's all so far. Anyone and any question, any concern on this one? If you have any questions, maybe you can put your question on the comment section, like the message section, and that would be great. Cool. So in this DSA, this is the basic class of number theory. And what is my agenda for this? First, I'll go to the basics roadmap, because whenever we skip the basics, we tend to don't like DSA in the future. For example, if you start working directly on the array and you see stuff on numbers, and you see there are some people who apply some magical formula to get the answer in the array question. So you say, okay, I understand the array is a data structure and this is how array stores value, but how did this formula create here, like how the people think about this formula. So if you don't understand those stuff like basic stuff of mathematics and those numbers part, you might not like doing more question on DSA on any topics like data structures of like arrays, strings, linked list. So if you start with the basics, if you understand the foundation of DSA with the numbers, in future whenever you solve any problem related to numbers, it will help you to understand how those things works and how you can also create the plan all stuff. Okay. So yeah, this is the basic roadmap, and probably it's gonna take 1 or 2 weeks, like 1 or 2 weeks in sense. 2 or 3 classes in each week. Okay, we'll start with the, as already started, the DSA initial basics math that we are going to cover in this today's talk, and then more maths on the next talk. And I'll try to make as simple as possible, right? And then going forward in the next talk, we will definitely talk about bit manipulation. It is tricky, but believe me, if you understand it, it will help you a lot. And in terms of interview part as well, like this, these questions are getting asked in Google and Uber and all those stuff. But you're gonna like the bit manipulation if you start understanding the basic part. I think it's very enough. And then your logical thinking. So logical thinking is something that, yeah, whenever we start programming, whenever we start doing coding in DSA, we first think one solution, right? We How do we improve thinking of logical part, like how can we solve it in different way? So we'll take some logical thinking questions, some puzzles, maybe some patterns, maybe just to improve your thinking. And each part of these topics, I'll help you provide some questions, maybe 10 questions. In the week itself, I will also send you some more questions, so if you have time, just go through those questions as well. Okay, so first understand the concept, then do some basic questions on those, and then some middle level questions. Okay, and one more thing, do not go out of your way to just do DSA. I'm just only saying, make your habit to do DSA in your daily life. As I said in the beginning, it will not just to give you confident, boost confident in your interview, but also your overall productivity. Again, cool. Let's start with the basic maths. Just give me a second, guys. Awesome. Let's start then. The number theory. What is the number theory? So, number theory is something that a part of mathematics where they work with numbers to understand what is number and the pattern in them and the structure, right? So, for example, the number theory deals with whole number, natural numbers, prime numbers, and it will help you to understand what is prime number, what is whole number, what is natural number, and help you to understand, find the pattern in those numbers, so that you can understand those patterns, and whenever you get the coding part of those numbers, you will apply those patterns to those questions to get your answers, right? So number theory is just a part of a mathematics which help you to understand numbers in a better way. What are the numbers, right? What are the concept of those numbers? How is it relevant in DSA? So numbers are being a huge part of not only DSA but in our software world itself. So for example, if somebody doing transactions, somebody doing cryptocurrency, right? Those security part internally, they have some kind of numbers running on them. Like for example, prime numbers are one of the core concepts in the security, right? Cryptography. So understanding prime numbers and how would you find those, the factorization of prime numbers, all those things will help you to understand the numbers better and organize in a way that create multiple algorithms. So having a basic understanding of these things, what is divisor, what is multiplier, I know you might, most of you might have already read this on your maybe schools or something, but here I will try to recall those concepts, and in a way that you can implement in a DSA. Okay, so in number theory, you have to understand what is divisors, what is prime number, how would you find those things, how you can extract digits from the from a number, those things. So that's how it's relevant in DSA. uh, where does it appear in coding problem? As I said, in terms of maybe handling numbers in a way that algorithm for maybe finding a GCD, LCF, right, of a number, those kind of concepts. If you go into the more deep side, as I said again, the security part, you will find a lot when you're working in the security part. You will find a lot of questions on number theory, right? So number theory is important on those concepts. Where are we starting with? We are starting with the divisors and then prime numbers and then digits and try to understand those concepts. Cool. So what is divisor? So divisor is basically a, a number which can divide any number with the remainder of zero. For example, as you can see here, a number d is a divisor of n. If and only if, understand, we only call d as a divisor because that d can divide n into remainder of zero. It can fully divide. The n is a fully divisible by d. Okay, that we call a divisor. Somebody might say is it could be a multiple of n. What is a multiple? N is uh, multiple of n is basically it can apply to some number that can become n. Okay, so in simple term, divisor is something that can fully divide any number. That means the remainder is going to be a zero. That we call a divisor. Okay, there might be a question like find all the divisors of a number, right? You might find, or maybe find all the multiple of a number. So using this thing, this formula, and this understanding of the concept that any number which can divide n, that we are finding a divisor of. So if somebody asks you find all the divisor of this n, so you understanding a divisor. What is divisor? Divisor is something that can fully like divide n without any remaining remainder. Okay, so that is we call divisor. We're going to have a question on this one in a few like in some time so that we can understand the divisor. And also there is one property that I added here, which is this one second, which is this even number is always has an even divisor. That you can, I think, remind, this is a property of a divisor, that even number is always has an even divisor and odd number is will always have an odd divisor. Okay, it's just a property. Maybe in some question when you are doing, you will if you have this property in your mind, you can maybe figure out more other ways to do the question. Cool. So that is the simple the definition of the divisor. It can divide a number with a remainder of zero. That's it. Cool. Here again, guys, this is just a basic thing, basic stuff to understand you these concepts. Cool. Uh, how would you get a divisor of a number? If I ask you to write a code to get all the divisor of a particular number. For example, if I say I want a divisor of 60, how would you get it? With this formula, right? We have this formula of divisor can only means that it can divide the number with a zero remainder, right? So that we call a divisor. First, so in DSA we call brute force approach. So brute force is that first approach that think in your mind. It doesn't have to do anything with the complexity of time or space. It's just that you come up with something which just solve the question, right? So we call those things brute force approach, right? So we just need to understand this with this formula how you can get this all the numbers of a you know get all the divisors of a number. So let's go to this place and let's just try to understand it. Maybe just let me create this here and just add me. Let me add. Let's say okay. So let's say we have a 60 as a number, okay, and we want all the divisors of it, like every divisor. So in terms of, so whenever you start working on any question, just see the question. Okay, so the question is to find all the divisor of 60 number. Now we know the concept that anything that can divide 60. So in our mind, like if you do basic calculation, 1 can divide 60, right? 2 can divide 60, um, 3 can divide 60. So with the basic calculation, you understand, okay, these number can divide 60. So until 60, everyone can divide, right? From 1 to 60, let's say. We will not go into the any optimization for now. We're just going through our mind. Okay, 1 to n is definitely 60 here. So 1 to 60 is definitely going to divide 60. So we will just check this formula we just learned, which is if the n can be divided by the number d, that means it is a divisor, right? So that we call a brute force approach. So in this can we write something like this? From We can write a loop from maybe while I to n. I hope you guys like familiar with the Java and Kotlin. So I'm just writing a pseudocode kind of stuff. So I will be start from zero. From you can start with zero as well, but uh, it will be a tricky on this one because zero uh, divide 60 will go to infinite, right? So that is not the part of this divisor. So you can start with 1, because when you do divide by 0, what it will do is it will throw an exception. Okay, check it in your local. So we'll start with 1. So we need all the numbers, like all the natural numbers, to check the number of divisors. So we'll start from I to n, and then what we can do is we understand this is the divisor, so it has to check if n modulus I. So what is this modulus do? Just let me just also introduce you this. So this modulus, guys, is just operator which directly gives you the reminder, right? Normally when you divide something, like for example, let's say you divide 20 by 2, you'll get the answer of 10, which is quotient for this, that if you multiply 2 by 10, you will get 20. So this is your cue, not your reminder. So if you just directly would like to get your reminder, just use this modulus operator. So that is why we have this modulus operator, which will give you just a reminder for this I on a n. Okay, so you just have this formula because we understand the divisors. What the divisor is, it's just a reminder of 0. So yeah, that's it. And you do this, and then you can print the number here. Maybe print n is a divisor. Okay, so this is how you get the number of divisor, right? So you understand the divisor, and you got the question of getting all the divisor of numbers. Since you understand the concept, you got all the divisors. Now this is just a basic approach and brute force approach. Now think how you can optimize it, like in a way. Now if you think more, you will get to know that, okay, I know that 1 to n is are all the numbers which can divide, because n plus 1 cannot divide 60, right? Because 61 cannot divide 60 because it's a more than 60. Now if we understand the numbers here, we can see one pattern. Okay, the pattern is, if you go one by one, 1, 2, 3, maybe 4, 5, 6, right? If you see, the last number which can divide 60 is 15, like apart from 60 itself. Okay, last number that can divide 60 is what is the half of 6, 60 is, sorry, 30. So this is the last number which can divide 60, right? So can we say that we can, instead of going from I to n, we know that 30 is the number which can last divide 60. Apart from it, like 31 cannot divide 60, correct? If you see the number, um, 60 divided by 31, you will get some kind of remainder of this one, right? So what you can do to improve this algorithm is, it's just to maybe n divide by 2. It can go up to n divide by 2, right? So until 30, now this whole algorithm is just cut down by half, right? So you make a more attention to this, to all the divisions. First you understand, okay, what is a divisor of this, and then you go more deep to understand, okay, how many numbers can divide 60. So that is 30. So which is a half of 60, right? If you go more inside of this, you will try to know that how we can optimize this whole function is. Before that, let me just include one more thing. uh, wait. So far, anyone have any question? Maybe, I think it might be more good to ask the question before moving forward. Do you have any question? I think no. Cool. Uh, how from here can you more think of it how we can optimize more, how we can go and can we able to find more optimized way, because our current running task and the time complexity I'll help you understand maybe in next part, because I thought number theory would be the basic concept so that you can also help to understand the complexity is nothing, just how many time it will take to run your code. So in this first example, it was n. Now we half it up. We have the numbers. Can we improve more? Uh, I would highly recommend, guys, whenever you do some question, just do not look the answer. Just think until your brains fall out your body, until you just take maybe 1 hour, 2 hour, maybe one day. I don't care. Just think about all the possibility that you can think to improve that question. At the end, if you can't able to do and your mind hurts, then you can go and check the answer. Until that, just think at loud what you can do. Okay, if you just go and just see the answer, you're not gonna get good at solving questions. Okay, it's okay for maybe first time if you're not able to understand it. Just to check some maybe hint instead of answer, what you can do to improve, instead of just going and watch the answer. So here, just think about it. What we can do here more. If you can see closely, guys, uh, we can do one more thing. Is if we do the square root of 60. Okay, if you go until the square root of 60, you will see the more optimized way. Okay, why I'm saying square root to 60? Let's do one thing. Let's try to get all the factor or all the divisor of first 60, and then I'll help you understand why how we are go to square root of 60. Okay, so first let's get all the factors of 60 here. We will get, for example, 1 into 60. First is 1, then we have 2, then we have 3, then we have 4, then we have 5, then we have 6. That is it, right? That these are all the numbers that can, um, if you see, wait, all the numbers that can go 6, then you have 10, then you have maybe 12, then you have 15, then you have 20, then you have 30. These are the numbers, right? But if you see more closely, after few numbers it's going to repeat itself. So what is the number that you can multiply to this 2 that you can get 60, guys? 1 you can multiply 60, then you can multiply 30 here. Here you can multiply 10, here maybe 15, maybe here 12, and maybe here 10. And maybe if you multiply 10 to what? 6, and then you multiply 12 to what is the number? 5, and then you multiply 5 to 15 to 4, then 20 to 3. Wait, what is the number? 20 is to 3, and then this is to 2. Sorry, it's 20, right? Okay. Did you see something here, like a pattern in this, all these uh, all these numbers that can divide 60? After a certain number, if you 6 and see through 6, it is repeating itself. Like that is you have to find, like whenever you do a question, just do your brute force, just get all your divisor here and just try to see the pattern in this. So you can see the pattern until 6. It's it's basically repeating itself, right? And what is 6 here? If you see, 6 is a square root of 60. So instead of going until 30, we can go until square root, right? Like, that can improve your number of iteration that you're going through to get all the divisor exponentially less, right? Because we just check each number that can multiply to some extent, and that is getting us 60, right? So we can see after 6 the number is getting repeat itself. Then we know that okay, until 6 it's getting repeat. What we can do is we can just go through 6 only, which is a square root of 60, and we can get the number, right? So we can write the code on this to understand. So that is we call a more optimized way. You can think maybe more optimized way. If you can find, it's good. If not, just check the answer and you will get to know that square root of n is basically a best optimized way to find all the divisor of a number. Okay, maybe let's do one question on this one. I added this here. uh, what we call find all the divisor, right? So have this. Here is the question. Is basically we need to print all the divisors. So I'm just doing just to give you understanding of this. So basics you can do, right? You can just go through each number and you can check. Let me do that as well. And I is equal to, maybe let's start with 1, and then here we will just go through until I is smaller than or equal to n, right? And then we can just check the our basic formula, which is n modulus I is equal to 0. This is our basic property, that what is a divisor. Okay, so this will just confirm us the divisor. So this just confirm us, and then we will print wait, I think this is Java, so we have to print like this. Print n, maybe ln, and then that's number I, right? That is it. This is it for to get the basics requirement of the number. That we have to compile this. Wait. Oh, oh yeah, because they are expecting a less very optimized way, but you can do it in your local machine. Okay, and you can check all the numbers that can divide. Cool. Because it's a, the comparative IDE, they will check for your space complexity. They are expecting in the square root n, right? So first go through the brute force so that you can understand the basics of, okay, at least we are solving it something. Now our next task was to go until n by 2, right? So n is equal to n by 2, and the same thing you can check in your local machine. Now in the square root part, okay, what is a square root? um, Square root is something we call sqrt of n, right? In the mathematics term, we call n into n. If we do the square root will remove, right? So this is what? The square root of n, correct? Like if there is a square root, if we have square of that number, we can remove the square root. So that formula you can also apply in coding. So you can check I into I, right? And you can check until n. Cool. You can also do mathematics terms. Like if you don't understand this, maybe go through this and maybe math.sqrt. Okay. This mathematical function is basically provide you the square root of n. Cool. And then I'm going with I into I, and then each time I'm going to increase I plus plus. Sorry, I think last time I didn't include that, but here forgot. Okay. Okay, just let's run this. Here, this is not right answer. I'll check. I'll tell you why. uh, k expected this, you can see I just added 1 2 4, right? Where is 5 10 20? You might be wondering, like, where is the 5 10 20? The way you can get it is, you can see 4 is a multiple of something, right? For example, let me show you. What was the number? Number was 20. Okay, so here let me just create another box. So here number was 20. Okay, so what is the 1 is there, then 2 is there, then 4 is there, right? Then we have 5. What was the other number? 10 and 20. 5, 10 and 20. Cool. So 1, what you can multiply is 20, then you get 20. And then in 2, what you can multiply to get 20 is 10. If you can multiply 10 to get 20, and you already have 20, you can you go, like, if you put the 10 in the other side here, it going to divide, right? And that's how you get 2 here. Sorry. So what I mean by that, if it's multiplying, so if you divide that number by that number, like for example, if you want to get 10, 10 2 is 20, right? So you're looping from upward side, which is 1 2 3, oh sorry, 1 2 4. If you want to get 10, what you can do is, you can just divide that number 2 to get 10, right? Same thing you can apply here. So in the same loop with the same number of iteration, is when you are getting the divisor, what you can do is, you can get another number, which is system.out.println and divide by I. So if n is divided by 2, what you can get? 10, right? If it's 4, which is a multiply of 5, you're getting 20. If you divide 20 by 4, what you get? 5, right? So let's just, in the same loop, we can get I and n divide by I. Oh, it's just that I'm doing print ln. I think they are doing not print ln. So let's just, and there is one more thing. Let me show you guys. Before that, instead of ln, print this. Oh, I think I need space. Wait, guys. Plus one. I think there's some issue in this one. It's saying, one of our friend is saying something. We can still print all divisor if print all the divisor if we print p and by. Yeah, this is the same thing. We can do the same on that part. 1 2 3 4. You can do one more thing is, maybe loop through the other part. That would be much better on this one. Maybe you can take it as homework on this one, because we are getting all our time. I have other thing to also consider. Yeah, you can consider this part as well to done that. Like, you understand the concept on this one, right? So since we have other concept to get, you'll able to get the, you can check the ascending part, right? You just check on this part. This is the same way that we can perform n by I. So it will give you the another part. Okay. Okay, I can just write all the answers, but I thought to do the live coding part. Sometimes it's not went well. Cool. The next part is a prime number factorization. Before the prime number factorization, let me just give you the prime numbers. Okay, we have 20 minutes just to finish this up. We'll go questions. No worry, guys. We'll go questions. Don't worry on those part. So, what is a prime number, guys? So, prime number is something that can only divide by one and itself. Okay, no other divisor is there. We have already know the understanding of divisor. What is divisor? Now think a number which can only divide by two positive divisors, which first it will be one and second itself. Now those number we call a prime numbers. Cool. So for example 2, 3, 5, 7. You see one thing here is 1 itself is not a prime number, right? Why 1 is not a prime number? It's just a simple answer. As I said, there has to be a two divisor. So 1 is only a divisor itself. It's only one divisor. There is no two divisor. That's why 1 is not a prime number. So always when you are doing code with the prime number, start with 2. Okay, because 2 itself a prime number, a number which can divide by two other number like 1 and 1 itself. Okay, so 1 is not a prime number. Cool. Since we understand the prime number, let me go back to this prime number factorization. What is this? This is very cool concept in this divisor concepts. So what is the concept? Let me just introduce here. Maybe go here and just create another. The prime number, guys, prime number factorization is help you to understand GCD as well. And they have questions on prime number factorization. So there might be a question that find me all the divisors who just a prime number. Okay, divisors, but only prime numbers. So if you understand this concept of prime factorization, you will get to understand, okay, what is this. So prime factorization, guys, is, as the concept says, the number or the divisor. You know the divisor, right? Divisor are those number which can fully divide a number and there is no remainder. Okay, so all the numbers, all the prime numbers that can divide that act as a divisor. For example, 2 in 60, in 60, 2 is a divisor, also a prime number, right? It is a divisor and it's also a prime number, right? So prime factorization is something which is all the factors of 60. So factors means something that can divide 60 by fully. So all the factors of 60, which is a prime, we call them as a prime factorization. So 60 can be added as 60 is equal to 2 into 2 into 5. Okay, so we call this sequence and we call this number structure a prime factorization of 60. Okay, so this is the concept of prime factorization. It is being used in multiple like algorithms. Okay, I have already added the questions in here at the last that you can also do on prime factorization to understand. Now, how do we get this? Like, how do we get all the prime factorization? First of all, we understand what is prime and we also understand the divisor. So we just need to add these two concepts. How would we do this? Okay, we know all the factors. How we can get the factors is I into I, which can smaller than n. And then in the while condition, we can check what is we can check is n modulus I is equal to 0. This will ensure that it will give us all the factors. Now we know the factors, right? The last concept. Now in this, we have to understand if a number which is dividing this n with the remainder 0, we have to understand if this number itself is a prime number or not, right? You can add those things together to create this and to get the prime factorization of a number. Okay, one of the simplest way what we can do is start dividing this number by prime number itself, the basic way. What is the basic prime number is 2, right? So what we can do is we know the first prime number 2 and we can divide this number 60 by this prime number. What we will get, okay, let's do it. So first prime number is 2. Let's divide 60 by 2. What we will get? 30. Right? Again divide 30 by 2. What will get? 15. Right? Next, what is the next prime number that can divide this? Let's go with 3. So 30 divided by 3, what we can get? 5. And then again, oh, sorry, here not 2 is 3. Here 5 can only divide by next prime number, and then we got 0. Let me just give you another example. Let's start with the 40. So 40 can be, we are starting with the initial prime number, which is 2. If we divide 2, 40, what will we get? 20. And 20 divided by 2, we are getting 10. And in 10, we divide by 2 again. What will we get? We cannot divide. No, we get to 5, right? Sorry. We divide, we get 5. And then 5, if I increase the number 3, 3 cannot divide 5. If we increase number 3 to 4, 4 cannot divide 5. 5 can only be divided by 5. So can we say that if we start with the prime number, the other number that can divide the remainder of the previous prime number can only be divided by prime numbers? So you can see the pattern here. In 60, if I start divided by 2, until the 2 cannot divide the number, the remainder of that, this expression was 15. You can see the remainder of 2 can only be divided by other prime numbers. Do you see? Do you see the pattern, right? In the 40 case as well, the last number that 2 can divide was 5. Now you can see there are no other number than a prime number that can divide 5. You can see the pattern, right? So that's how you can get the basics of, of prime factorization. Is you can just start with 2, and then you can divide that number until uh, it is cannot divisible, and increase the number, because each time only the prime number that can divide. So can we write a formula here that instead of, if let's do the while loop again, n is equal to n divided by I. Okay, we are starting I here by 2. Now when this loop, the inner loop, as you can see, each time we'll see the remainder, right? Each time we'll see if this I can divide n or not. If it's not able to divide n, just increase the number, plus plus. Now take example of 60. Let's start with 2. It 2 can divide 60. Yes, 2 can divide 60. Now goes inside. 60 is equal to 60 by 2. Answer is 30. 30 can divide by 2. Yes. Then again it go inside, and 30 can be divided by 2, right? Which is 15. 2, 15 modulus 2. The remainder will be something, maybe 5, which is not 0. So we increase the number to 3. Now 3 can divide 15. Yes, it can divide 15. So it will divide this here, and again it will come 5 here. 5 modulus 3. Can 3 divide 5? No. There will be some remainder, right? So in case of, now from 3 we goes to 4. So because it's I plus plus, right? If again it will go to for loop, and it will see, can 4 divide 5? No, there will be a reminder. It will go again, it will check I plus plus, and 5 can divide 5. Yes, it can divide 5. So these are all prime factors of 60. You got the answer, right? So this is how we can get the prime factorization of a number. Just start with the prime number, and it will ensure that each remainder will give you another prime number to divide. So understand this concept, like understand the prime number. So whenever, so we understand the concept, right? Whenever we divide some number with prime number, we will get a remainder which can only divide by a prime number. So it's easy to do the prime factorization. You can also initially, when you don't get this answer, start with the prime number. Just first do I first run the loop until square root n, check this if condition, and you can also check, uh, you can also like add another while loop to check a prime number or not. How you can check if the number is prime, not a prime number or not a prime number? Basic formula. uh, Loop through it, loop through maybe until the number, okay, and then check if any number that can divide, like that can divide that number, which is this divisor, right? Any number like from 1 to n, maybe let me just write it here. From 1 to n, any number, if that number can divide n, it's not a prime number. Okay, so maybe you can add another while loop here just to check, because the brute force approach, just do check on it. Next time when you do this prime by 2, you will understand, okay, this is also one of the way that we can get all the prime numbers, that if you divide any prime number with a number, you will get a prime numbers, like the remainder will be a prime number and it can only divide by another prime number. Okay, this is just a basic formula to get uh, if a number is a prime number or not. Guys, can you see one more thing here, guys? Loop until if the number is divided by I or not. What is the complexity, time complexity will be here? You remember all the divisor that we did here? What is the higher number of divisor, which is square root of n? So this loop will also be going through square root. Okay, do not just run from 1 to n, because you already know all the divisor, doesn't matter is a prime or not, it has to be until square root of n. Okay, so whenever you are getting, if there is a program and they want you to check if number is prime number or not, don't just go check from 1 to n, because you already know all the divisors, doesn't count any prime number, whole number, rational number, doesn't count, it will be square root of n. So so the algorithm to find the prime number itself is a square root of n. Hope you get the idea, like what is a prime number and prime factorization, or how you can get all the factors which is prime. Cool. I know it's a lot to take in. I already recording this, so you can see like in future. Now the last part of this session is this GCD. So GCD is basically, guys, what is the greatest common divisor? The highest number that can divide two numbers. Okay. For example, I think I already had the example here. No, I don't think I had it. Okay. Here, let's take what is the GCD. Uh, Maybe you can say 10 and 20. What is the highest divisor that can divide both of them? We can say 10. 10 can divide a 10 itself, and that can divide 20. Is there any number, highest number, that can divide both of them? Maybe you can check. Okay, so any number that can divide both numbers, and that we call a greatest common divisor. Okay, that we call it this GCD. So there is an algorithm which we call Euclid algorithm. What it says, guys, before that I have to make you understand this. This is the theorem that is given by Euclid, and then this theorem is help us to find this GCD. What is this theorem? This theorem says A is equal to B into Q plus R. What is this? See, guys, this formula we just pick it up. A is equal to B into Q. Q here is the quotient. So whenever you divide something, so you divide 20 by 2, you get 10, right? This is Q, and remainder is R. Okay, so can we write A, which is 20, is equal to B, which is divisible, into Q plus remainder is 0. Any divider, guys, any divider, like either it's dividing that number fully or not. Can we write that number, like if we write like 25 divided by 2? Can we write like 25 is equal to 2, which is we are dividing, and then 10 plus 5? So Euclid says this is the formula applicable for every a or b number. So a is a divider and a is a divisor. Okay, divisor is something which is dividing a. So b is dividing a, so the formula is b into quotient into remainder. Okay, so based on that, he says we can find the greatest common, the divisor, GCD. What is that? If I added this, so as I said, the modulus part, I think I already explained. The modulus is just a reminder. uh, and in the GCD, what it says is, if you want to find a GCD of a b, then what? And it will be equal to b a modulus b. Let me explain you what is this. So if I want to find uh, 20 and 10, what is the GCD of this? GCD will be always 20, 10 is always going to be a GCD of 20, uh, 20 modulus 10, which is 0. No, I think so. Sorry, it's B actually, which is 10 here. Okay, so it says whenever you want to find a GCD, it will be a, if I convert this into formula, guys, how it will look. Let me just confirm this. Eh, okay, so if formula, if you see, A is, what is A? A is 20, right? And B is 10. Now A into, sorry, B into Q plus R, Q plus R. Now 20 is equal to 10 into, what is it? 2 plus 0. Okay, so it says the next GCD will be B, which is 10 here, and the remainder. Okay, the remainder here was not 10, it was 0. This always, and whenever guys, whenever your remainder is 0, then your answer will be your A. Okay, if it's your GCD is 10 or 0, whenever you get remainder 0, guys, your B is your answer. In this case you get B, but let's say if I have maybe 8. Okay, can we calculate this? Cool, let's calculate. For 20 is equal to, what we can multiply to 8, that we can close to, that is a multiplier of 8, and that is going to close to 20. So we can multiply by 2, because 8 into 2 is 16 plus 4, because if I multiply 3, guys, it will go into 21, right, which is more than 20. Cool, let me just maybe close this for this. Right, now the next GCD will be B, which is 8, and what I said, B modulus A, which is remainder, which is 4. Okay, now again do the GCD of it. What is the GCD? What we can do to get the 4, what we can multiply into 4, that we can get 8, like close to 8, which is 2. In this case 0 is the remainder. Now the GCD of B, which is 4, and remainder is 0. As you can see, guys, last time was what I said, if you have GCD of 4 and 0, the GCD will be 4. Now the GCD of 2 and 8 will be 4. You understand, like we have to loop it through until we get the remainder of 0. Whenever we get the remainder of 0, that B will be the GCD. So if you calculate like if you do the GCD manually, you will see 4 is the greatest common divisor of 20 and 8. This is what this theorem says, that do GCD of B and remainder of like A in modulus B until your this remainder gets 0. Okay, maybe you can try out in your free time, like the algorithm here. What will be the just simple algorithm? I think you can just do GCD of A comma B. You can see if B is equal to 0, maybe return what you can return. If it's 0, then B will be, sorry, the A will be returned. Otherwise, GCD uh, your B comma A modulus B. Can we write this? Like just a simple way that I explained. GCD is a function name, guys. So just a function, it's a recursion call, okay? Just make recursion is something that it's call itself. So if I say GCD and then the same formula, guys, that I apply here, GCD B, make B to A, and the next B will be the remainder. You see, and the recursion end will be if B is equal to 0 until your return reminder is 0. Just do the GCD. This is the simplest way to implement this algorithm, and that's how you will get the GCD, greatest common divisor. In terms of implementation, if you don't understand, let me know. What we did is we basically did this formula: A is equal to B into Q plus R. Here Q is multiply a number which get close to 20. So in case of 8, 2 is the only multiplier we can get to 16, because if I multiply with 3, guys, it will more than 20. So in this case we multiply into 2 and the remainder was 4. Now do the again GCD of 8 4, as I said B, because here we were finding 20 and 8, right? GCD of 20 of 8. So the next GCD we will find is, arey yaar, we will find is 8 and the remainder, right? In each time, as I said, you guys, reminder. So here reminder was 4. If you find the GCD of this, which was 8 is equal to 4 into 2, the closest number is, if I multiply 2 to 4, I get 8. So here reminder is 0. Now, if I do next GCD, which is 4 and 0, the GCD of like this one, as I said, if your reminder becomes 0, your GCD will be 4. This is the final answer. Like this is the whole algorithm. Like divide, do the GCD again until you get your reminder 0. Whenever you get your reminder 0, your A will be your the GCD of this 20 and 8. This we just implemented here in course of like in terms of this coding part. You can see I calling the same function, but I change the position of B to A and B to the modulus of this. Okay, this is the real world, like what is this doing, and this is just a simple way to do it. You can do it using loop as well, no issues. You can use the maybe for loop until like infinity, until your condition get mapped, because you don't know, how many steps is gonna take. So do the while loop until true, and if there is this condition match, then just exit the loop, maybe break it. Cool. So instead of doing recursion, you can do while loop as well, because you don't know, as I said again, you don't know how many steps it's gonna take. So do the infinite for loop or while loop. Cool. So that is the Euclid algorithm method for GCD. Hope you understand what is A, what is B, what is Q, what is R. Cool. These are the guys question that you can perform using modulus, using prime number, and this number theory. So all these things that you have learned today, you can apply it, and you will see you are able to solve the questions. Understand modulus, understand prime, understand divisor, understand GCD. These concepts will help you if you go to do all these questions. I have maybe added this. There's a link. You can go and do the questions. You are able to solve it. If you not, let me know. I think it's more than time. Uh, that's it for the session today, guys. It's just a basic one. I know it's just a basic, but still like something to go. If you have any question, guys, maybe you can put in the maybe in the message. Shivam, when is the next session? Oh, the next session will be probably next week. Each week, I'm going to take like sessions so that we don't go out of a track. Okay, and yeah, I'll share this to you guys, this PowerPoint, so you get questions at least. And if you have any problem, guys, while doing it, let me know. Ping me as well. I'll happy to help. Cool. I hope you understand like 10%, 20%, something about the prime numbers, the other things. Cool. Uh, maybe guys, please ping me your numbers. Why I need this is maybe I'll keep check on you guys that what you guys did in the last week, because I want like people who are like fully focused on this one. That would be like good. Maybe ping me on like we have my number from WhatsApp, maybe Telegram. Just ping me, and I will keep your number to check your updates. Cool. And if you are, and also if you're Android developer and there is opening in Gojek, let me know. I'll also refer you guys. I think they were hiring for senior Android engineer. So if you are wanted to have interview in Gojek, let me know. Cool. Thanks a lot, guys. Thank you so much for joining, and I'll share you the video and this DSA. Awesome.